made fillet weld. Back up here on the PowerPoint. So here we see a good example. We've got a 1/4 inch weld, 1/4 inch leg, so the weld size, it's convex. So we automatically know that our leg size and our weld size are the same due to the fact that it's convex and not concaved, okay? And if you notice that it's the exact same size as the material that we're welding. Perfect. Leg is appropriate for the thickness of plate. Excellent. Over welded. Here's a good example of the base. What it states here is it says it's over welded. Over welded. The base metal will break at the toes of the weld. Legs of the weld are too large for thickness of plate. I have seen this more times than you can imagine. Somebody will put, they think, it broke before, so I'm going to put twice as much weld on it. That's so much better. Absolutely not. Remember, that's a lot more added stress, it's a lot more weight, it's also a lot of distortion. So as you have these two pieces of material, and you put that big weld, you're already putting stress on it to pull it this way and kind of contract. Because as we weld, what happens is that weld contracts. And it'll pull the two pieces together. Okay? So in this case, we're double the size we need to be. 1/2 inch leg weld, so that's a tremendous amount of weld, especially for that thick of material. I've seen them time and time again. What happens is they'll crack out. A lot of times they pull them together, the vibration's there, and usually one of these will have less fusion and penetration into the base metal, so it'll crack out along the edge and this whole piece will fall off, or vice versa. Okay? If not that, it will start here, all the vibration will impound on the toes, and it will start cracking through the material that direction. Okay? Underwelded, here's another good example. Now this isn't always a situation either. We have to use our head about what we're doing. Okay? If this is just holding a bracket on for a picture frame, or a piece of artwork, that's completely different than a structural building that's going to see vibration, static stress, load-bearing weight, quite possibly some cyclic activity as well, going up and down the road or something like that. We're going to weld the two very different. If it's a piece of artwork or just a light bracket to hold the arm of a computer up or something like that, completely different. We don't have to have a 1/4 inch weld. Maybe we only need an 1/8 of an inch weld. But if it's a structural steel welding that's going to hold any vibration or so forth, we usually want to make sure we at least match the base material. Okay? There we go. Since I've been saying since the beginning, a weld or weld joint is no stronger than its weakest point. So again, the weakest link is where we size the weld. That's the weak point, the smallest port. Thickness. Again, there's the metal. So in this case, here's a good example. When do we need an equal leg fillet weld versus an unequal? Perfect example. Say this was on the bottom of a deck or a grating for something, a building. Okay, it's got a 1/2 inch plate because it's going to have several people on it. We need to make sure that this part of the weld, this leg of the weld, is sized correctly. But what if this was the handrail and it's a very thin wall tubing? We don't necessarily need this to be a 1/2 inch weld because it's not going to see as much weight. It's going to see a lot more vibration. And again, we've seen with the vibration, it's going to contract, create more stresses. So we need to make sure that we weld it according to which side we're doing. So this is what we call an unequal leg fillet. It can be designed this way. Wasted metal, time, more stress, so forth. Right here it says the weakest point will be at the toes of the 1/4 inch plate, right there. Weakest link. And you'll see this quite often on handrails. Equipment going up and down the road. Somebody thinks they got to over weld it, and they've actually made it worse than it needed to be. You know, this is a big thing as well. The thinner the material, you need to make sure that it's the less heat input, the smaller the weld you put in. The more weld you put in, the more heat input. Okay? All right, weld length. We're on page 124, chapter 4. As we're reading down through this, we will talk about it and discuss it. Fillet and groove welds usually made along the full length of the joint. In some cases, the full strength of a fillet welded joint can be achieved by only welding a portion of the joint. The effective length of a fillet weld measured as overall length of full-size fillet weld. The start and stop of the weld must be allowed for. Make sure that it's not square, so the allowance made when measuring. We're going to talk about that here in a second, okay? So let's go to our book, 124, page 124, chapter 4. Look down through there, you see pitches in bold writing. Weld area and stress are easily calculated. We're going to break this down and talk about it here in a minute. Okay, I want you to look through that, take a break, we'll start the next section.